So, so I would like to get started on this kind of very famous quote. Is the how can we keep going? How we can keep moving like musicians who keep performing during the concert after making mistake. You probably never heard about this one. That's because I actually said. So it's yeah. So nobody famous saying this one, but. So so my name is Juti. I'm a senior software developer at Stafflow, and if you want to know anything about it, just go Google for it. That's probably easier for my slide too. So first of all, this might sound funny, but I'm not against all the tests. It's awesome, but in this case, I want to kind of like mention that, you know, like when you're in startup, you don't have a lot of time to actually like to implement tests. You know, the company might not even have resources to hire all developers so that you can write all like unit tests, functional tests. So so basically, this is like the situation that. So how can we keep moving on without any tests at all, or maybe just minimal tests, but not enough to so that, you know, we can make us confidence. So like and also, this is like kind of the kind of topic that kind of just showed that how can we think about designing software before we think about testing. It might sound funny because a lot of people would say TDD, like test-driven development, would be like think about tests before you think about writing code. This would be the other way around. And also, like I just mentioned, that since we don't have tests, it's not really an option. So this is going to be like really fun topic because I know that 2 sessions earlier, or maybe so they kind of talking about the test, and now I'd say that just forget about tests, right? So let's see, before we get started further, so the first thing is we're talking about the maintainability. So what is the maintainability? I mean, people can keep talking about this and like, oh, my code is really maintainable, but what is the measure? How will you say that this code is maintainable? So maintainability is a measure of the ease in which a piece of software can be maintained in order to isolate defects or cause, correct them, repair or replace defective one without having to modify this still working one, and make the future work on any of these components a lot easier, and resist to external change. I'm not going to go deep into all of this, but I'm going to kind of keep explaining about this along the through the course of this session. And now the fun part is, well, that sounds fun, but what if we don't have tests? What are we going to do? It's still not like impossible to achieve all of this. It just make it really difficult if you actually just, you know, like do it without actually thinking, like just go ahead and do the coding without actually thinking about it, right? So, so now the first thing that we can do to actually to make your code maintainable is put into the right mindset, which is try to keep it lean and simple. Like I just keep mentioning earlier that you know, since the testing is not an option, so speed is all that matters. And what this means is that since we don't have a lot of time to try to understand the code, so the code have to be really simple. Like by simple, lean and simple, which is mean that when you read the code, you should be able to understand it in the short time. You don't have to like start reading on this one, go to the next one, and go to the next one, next one, next one. Like you have to go through 7-5 before you can get back to the code and say, oh, this is how it works. Thank you very much for actually try to write the code that look like, you know, like the Legend of Zelda, that you have to go all the way to the boss, and in the end, oh, that's all the story about. Thank you. And then in this case, I know that some to a lot of developers love the defensive code. Sadly, most of the time you don't really need it. It's because defensive code is good when you actually write the code for someone else to use it. But when you work in a company, sadly, most of the time you work with the internal code. And even if you use the open source, you actually don't really care much unless someone crazy like me or some of my friends who actually go there and try to figure out what it's actually doing by reading their code. So since most of the time you deal with the internal code, you have full access to it, the misuse is really unlikely. So you don't really need the defensive code. If it's break, it's break. That's good because, I mean, you should use it properly. If it's break, that means you're actually doing something wrong. And only cache exception that you need. In this case, similar story. Python actually have a lot of exception, and you can actually cache all of them. But imagine that you play the Pokemon Go. Seriously, you're not going to cache all of that 105 monster, because by doing that, you're not going to have time to do the actual work. So you need to cache what is really necessary. For example, you write a block. So you are working on the code that say, oh, I load from the database, put into on the page, and then that's kind of what it's supposed to do. So seriously, you don't have to write the exception that's cached, say, syntax error, because, like, for example, SQL error, because you're supposed to have the correct SQL error before you start delivery. So, but if, for example, like the database connection error, you will say, oops, now you have to do something about it. That's kind of exception you should be caching. So think about before you actually start caching exception. Not all of them you need to cache. You just need to cache the right one. And the last one, I know it's kind of pushed all the way down, but keeps cyclomatic complexity really low. And now I know that everyone start asking or start going on to Wikipedia and thinking like, what is that cyclomatic complexity? The easy term for that thing is basically the number of possible execution in your code. So for example, you start off with something like let's say you want to create the addition function. So you have like parameter A and B, right? So the simplest implementation would be just return A plus B. So that's all done, and everyone just go home having a beer. But sometimes when you come back and then your manager say, can you write something, say like, I don't want to like just keep getting integers. Sometimes I want to write put a string like 1.2 something, and I want the addition function to work. So you have to go to the code, add like the code and say, if this one is a string, then you cast a string into an integer. In this case, you are looking at the in this case, first of all, before we start adding this, that one only have one possible execution. You cannot have more than one. It's impossible. But now when you have when you have to add the condition, say I pass it as a string, and I need to be able to do the addition, like I pass as integer. That if condition is now becomes the second possibility. So even if there's only one return, but that's actually become like the next possibility. So that's what is all cyclomatic complexity is all about. And by having high numbers, for example, you might have a code that's say, I do this if not do that, if else it's not do that, and when you have all the on everything, that's make it more complicated. More condition you have, even like the optional parameter that you have, that's increase the complexity, and that's making complicated to the point that you might not want to work with that thing anymore. So cyclomatic complexity is really important when you write a code. Be careful about trying to get that number too high. And the nice thing about this, the reason why I say keep it low, not because it's to make things unnecessarily complicated, but it's also when you actually have time to write tests, the number of tests, so you will see that if you can keep this clean and simple, you got the simple implementation, easy understandable code, low cyclomatic complexity, and low test complexity. And that's actually mean that because when we're talking about the code coverage, we're not talking about in terms of like, oh, how many lines that is that when you rerun tests and it's actually like that line being executed. It's talking about how many possible execution path that the test actually can cover. So the minimum test coverage is actually based on it's exactly the same as the number of execution paths. So if you're actually having lower, it's probably bad because you actually didn't cover all of them. If you have more than that, it's probably good, but you probably shouldn't be doing that. You should be doing something else. So that's a fun fact. I forgot to mention about that thing on the top. So now the separation of concern. When you first thing is the concern. When you think about the concern, it's more like a problem. When you write code, for example, you try to do like this like for example the addition function, you want to think about the just adding two variable together. That's one problem. When you're thinking about, oops, I have to check if the if it's a string and then cast it to integer, that's another problem. That's another sub problem. You have to kind of try to break it down. So that's kind of what is about the concern, right? So separating concern, I'm gonna kind of just read this out. I actually can't just read it, but basically it's like separating a computer program into a distinct section. That each section address a separate concern, which is actually from Wikipedia, by the way. And so the benefit of this is when you can implement test case for a particular section without testing the whole program or subroutine. So, like for example, at the addition example is actually pretty small, but what you're about to see next is probably something that you will be appreciating by if you actually kind of just separating everything into like a sub problem. And also, it also can be easily refactored because you kind of can't tell what it's doing, and you can just move the code around without messing up the the reference order. And so, for example, like this example, it's kind of you take and it's kind of like the command line code. So you kind of just take it, define the parameter, and do all that kind of stuff, and then. If I try to separate this into a different by concern, right? So this is what it's going to look like. So we have one to just define the argument. We have one to just load the configuration, and the main one is just doing what it's already tried to do. It's probably have a lot more because I have like the dot. I can't fit the whole thing in one slide, but you see that from here, which is. You can actually, it's simple right now, but without like any kind of indication, like without separating all of them, you kind of spend some time to try to figure out what it is by line. But when you have this, it will be a lot easier to see what it is by just looking to the function. You can technically test each function, but we're not going to talk about the testability here because that's not what this talk is all about. And so the next one is a single responsibility, and I know this is long. This is basically someone Robert C. Martin actually talking like on the definition, and I'm not going to read this. You can actually just go grab the slide later on, which I will give you the link. However, the responsibility in this case, if you think in the simpler term, is actually like duty. It's kind of like each responsibility is like a duty to solve one particular problem. In this case, it's also a single responsibility also isolate the problem by functionality, and with the proper design implementation, any component of a computer program can be easily maintained with minimal or no impact on each other. This statement might sound really funny, but then in the next few slides you will see why this is actually maybe the case. And most of the time when we talk about single responsibility, the one design pattern that really helpful in to help you achieve that is the context-based design, which is something that you might learn in your university. Like for example, like talking about the precondition, post-condition, and something like that. That's all the contracts. Like that's kind of like so think of precondition like what you should give to the function, and that's kind of like what are you trying to do, something along that line. So that's the context-based design. So back to back to from the previous progress that we have from the original code. You see we have all the separate all the concerns here, and now we actually now split it up into multiple files. This one is basically just handle everything from the the user input from the terminal. So you see that it's actually defined the parameter here is run execute the code from the main script from the previous example, and this guy is do the configuration loading, and this one just basically just the main script that kind of put everything together and make sure that the run function is being executed. But you see that by separating everything into by separating it by responsibility, if something's go wrong, for example, like you are passing in like the configuration part and something doesn't work right, you probably like for example, you just pass and then it doesn't look like it's loading any files. You maybe look into this one and say, did I actually pass the configuration files here properly? If that one is fine, then now you can look into like, or is the load function actually even working? Look like it's, so that's kind of like, so it would be a lot easier for you when you actually like, when you don't have tests, when you don't have anything like that. It's kind of like just kind of like the mindset that you can make it easier to identify where the problem is, and you see that it's isolated problem. So now you're thinking that, oh, now passing parameter is not really a problem, so you can forget about the whole files, and then you can look into just that one, how it's actually loading the configuration. And have anyone ever heard about dependency injection at all in their life? Oh, thank you. And now this is going to be really entertaining for the rest of the room. So dependency injection, let's say that we want to decouple our class from dependency, which is kind of sounds really fishy now, is that this dependency can be replaced or updated with minimal or no change to the class. That sounds pretty much similar to what I just said a few slides ago. And also, additionally, if the time permit, we want to like test our class in isolation without using dependency, which is in this case like a unit test. So you can think of any like we can just use a mock object instead of the actual class that we require, just as long as the contract is still being defined properly, implement properly. And lastly, we don't want our class to be responsible for locating and managing dependency construction and resolution. This is pretty much something like if I just go back a little bit, you see that none of this that I has been doing so far is ever talking about, say, ever like construct the config loader in the init or anything like that. That's also kind of like just kind of show off any responsibility about like constructing and everything together into just that one file. And so I want to do some explanation, but before we go with that, so this is kind of the general term of the roles in dependency injection. So we have the service, which is like the object that you want to use, the client, which is the object that depends on the other services, and the injector, which is responsible for constructing services and injecting them into a client, which is basically kind of like the guy who actually just make everyone united together, that kind of thing. So back to an example without all the text that I put earlier, and now you see that that file, which is actually kind of just a little bit too high there when I put it, you see that that guy is the injector. The reason is that because the main function is actually do all the construction and put everything together, like what I just keep saying for the past 5 minutes, and you see that this is also like the first line would be like the constructed service without dependency, the one with dependency, and you see that this file kind of put everything together, and then as you see that the loader in this case. From this example, I'm actually used JSON because I kind of ran out of idea. But in the future, when somebody come in and say, like, Juti, you need to support YAML files, you need to support XML files, which probably nobody using that nowadays. But thinking of I need to support multiple file type, so the code, so the console need to be able to load, just load any type of file. So so in this case, if I can just replace that loader, which is just a JSON loader, to be something like YAML loader and something like that, as long as it take the same parameter, it's have the same method, what is implement in the method in that loader, it doesn't really matter, because all that matter for the console class is basically I just need to call this function, and then I just need to get the result back as a dictionary. That's all. That's all this one cares. So you see that this and you see that this particular feature for the dependency injection, it can be used in testing, where you can actually just replace that loader into something like a mock object. So like when you write test, you might say something like, oh, you can pass the config path as long as it's not empty string, and then you just return the dictionary because it's a test code. So why would I care about what is actually loading? So you can do this with the unit test. So it's actually being commonly used, like this particular pattern is being used in Java, mostly like the Spring framework that kind of use a lot of this dependency injection, and also Symfony framework in PHP also doing this too. Python have a few of them, but these are the two that I'm actually kind of find that is kind of usable. But yeah, so you might want to take a look at it. They both implement in the different using different pattern, like different way to set up, but they're kind of they're kind of talking about the same thing, where you each class is not responsible for constructing and managing all of this dependency. There'll be one guys to do it, and then that's kind of, so there's only one point of entry that you can ask for which service I want to use. And it's just taking care of constructing and getting all the dependency injected properly. So basically that's kind of the same idea. So there are these are the few foundation for the achieving code maintainability, even if you don't have a complete or usable test automation. There are a lot more, like because I'm pretty sure that I don't have time to cover everything. So for example, solid design principle, which is, if anyone ever heard about this, is two of the design principle already been covered in this slide, like the single responsibility and the dependency injection. That is part of the design principle. Adapter pattern, it kind of like you want to try to look at this one. It's really interesting. Think of it like some kind of like when you have like an application that supports multiple type of database, you need to you need an adapter for MySQL and one for Postgres database. Sorry, 1 second. Oh, water. So, and then there are a few more that you probably, it's probably like something you heard about, like factory pattern, repository, unit of work is also very interesting. Oh man. But unit of work, you might not have chance to use that a lot. Also, it's really complicated. So you can just ignore it. 1 second. Oh, geez. But just to be careful, all of this is kind of good, but if you overuse it or overdo it, it might be a problem. And just keep in mind that code readability is actually really important. It's like what I keep mentioning, that we don't have a lot of time. So we need to make sure that the code is being implemented in the cleanest way possible, that not just you, or maybe it's you too, but not all humans actually remember everything forever. So especially me, like a goldfish memory. So you kind of, so like I write the code 5 minutes later after a few interruptions and come back, what did I just do here, right? So you have to make sure that everything is kind of clear, because you never know what would happen. And also, I know Python is really readable, it's designed for readability, but if you try to write but it can be messy. So, and that's a problem, because messy code actually kind of psychologically, it's actually kind of make you feel like you're reading the machine code. You kind of like, you see like the Python in one liner that's doing like 20 different things. think of like a pulse, the same thing. Like you have like 20 things to do at the same time, and you'll be like, oh, cool, this language. Okay, let's find different one. So so readability is really important in terms of maintainability. Like for example, this one. Is anyone can understand this in 5 seconds? 4, 3. Okay, I guess you probably don't know, but seriously, I don't. When I write this one, I have to double check a few times. Like, what I'm actually doing here? Oh, cool! And especially like all of this nested. This is probably running, but yeah, seriously, don't try this one. This is actually pretty bad. The next one is engineering, and this is only one slide here, but and also a lot of people know about it. But a lot of people still make mistakes, including me. Like for example, abstraction. Just make sure that you don't do early extraction. You might see like, oh, code duplicate. Oh shoot, like you have like one that do exactly the same thing, like in 2 different places. But sometimes you don't actually need to try to combine them together until you actually try to run into the problem where, okay, this is have too many duplicated. Is that, like let's say like step flow, we kind of just go say 5 places is already more than enough. We start abstracting, but if it's just 2, nah, we can just live with that for now. So early abstraction is a problem because when you start having more code that try to do the same thing, but you try to add a few things that's slightly different, you start adding more condition, and that's actually come to like the cyclomatic complexity that you start adding more condition and become more complicated than what it used to be. So try not to do early abstraction, premature extraction, or even excessive extraction. The last one is would be like, for example, if you have a model, you want to represent about something like the human, the insect, the elephant, something like that. But if you're kind of thinking, oh, I'm gonna have to do all of this. This is like my project. So you start like abstracting, like so go all the way down to class called organism, and you start down to the mammal, insect, and then all that kind of thing by the biological family. Then you get into trouble because later, because like this level of abstraction, sometimes you might feel like, oh, this function is gonna be in everywhere anyway, so let's put this one. And then later on you'll be like, oh, but I want to do this. I want this function to do slightly different from the parent's function. You start overriding, and all of this. Sometimes you might say, oh, I want to do the one in the parent class, and then after that I will do this. So this is where like when you start looking at this class and you still have no idea what this class is actually doing, so you have to go into like back. One worst case I used to see is like a 7 level of inheritance that like the kind of combination of like a tree interface and like four objects. And this is not just limited to Python, it's also go to like a PHP, Java, and all that kind of stuff. When you're having this level inheritance, you kind of get, even if you look at the class, you spend a lot of time, not just like, you want to understand this by just look at it. So be careful with this one. The attempt to solve the universal yet unknown problems, I kind of try to put a fancy word here, but basically it's a rocket science. Like, for example, you kind of know, oh, the client wants this, but the client might not need this one, but there might be something else. This kind of but, if you don't actually know what it is, don't try to handle, because in the future, because a lot of people probably see this, but you know, when you kind of going out and then eventually you kind of they change the business requirement and kind of stuff, and then you're like, oh, cool, but you told me like about 6 months ago you're gonna do this. So 6 months ago I also implemented this one, and now you want me to change it, so you have to go back and try to unpack it, and now it's become a mess because you start adding more condition, even though you might leave the old condition there, so you kind of have a lot of unnecessary code there that's not actually using it. So when you try to find investigate a problem, you're like, is this code actually ever been used at all? Or is it still being used? You have to search for the whole code base. And if you have multiple code base, good luck. You have to like check out all the code repository and try to figure out which one not being used. So rocket science, just avoid it. Leave that to NASA. Or something European equivalent, just leave them there. The last one, circular dependencies. This is probably much simpler by just saying that this is a chicken and egg problem. Basically, don't try to make two objects that depend each other, because you never know which one is actually coming first, and even anyone gods probably cannot tell what it is, like because you don't know, should I construct this one first, should I construct this one, but something like that. So yeah, so that's it. That's my contact information, and this is all the stuff that I think that might be useful for you guys. So thank you very much.